Okay, this is 11.3 systems of equations by elimination. So there's a brief description of what your textbook has right there on the first page. But we're going to jump down to these problems. And with these problems, ideally, these are set up for elimination if you have variables with the same coefficients but opposite signs. So if you look right here, you have a negative y and you have a positive y, okay? And so they both have a coefficient of 1. One has a negative 1 and one has a positive 1, so they are opposite signs. And so these are set up ideally to add these equations together. And so just like when we add numbers, you know, if we added 372 plus 408, we line up our numbers and the ones place gets here and then the tens place and then the hundreds place. And now when we're doing equations, we're going to add our x's together. So 1x plus 1x is 2x. Negative y plus positive y eliminates, and 2 plus 8 is 10. And so this brings us down where we have one variable, and now we can solve it. And so when I divide by 2, I get x is equal to 5. Now I still am going to have to substitute, and it doesn't matter which equation I substitute in. I'm going to use this one. And so I am going to take x, which is 5, add it to y, and know that I get 8. And so that tells me that y is 3. And so again, I will list my ordered pair as the solution 5, 3. Okay? So this one is also set up ideally for elimination. And if you look, we have a positive x and a negative x. So we are going to draw our line and add these two equations. These x's eliminate each other. Negative 2y and positive 5y makes 3y. And negative 11 plus 23 makes positive 12. And then I solve by dividing through by 3. And so y comes out to be 4. And again, I can plug it into either one. This time I'm going to go in the top equation. X is, not equals, x minus 2 times y is equal to negative 11. And so x minus 8 is equal to negative 11, which says x is negative 3. And so I write my solution as an ordered pair, negative 3, 4. Now, sometimes our method is, our equation is not set up ideally to do elimination, but in this case, you can always manipulate an equation to find that method of to use that method of addition. So what they do is they tell you, you want to look at the variables, and the variables, I've got a 1x and I've got a 2x. And then I've got a negative 1y and a positive 3y. So the easiest one to cancel is going to be the one with the opposite signs. And so if you notice, what they'll have you do is they're going to have you multiply the first equation by 3. So I'm going to put 3. Now I like to put arrows here so that I don't forget to multiply everything. So 3 times x is 3x, 3 times negative y is negative 3y, and 3 times negative 1 is negative 3. And now I can add them up. And so 3x plus 2x makes 5x, negative 3y and positive 3y cancel, and negative 3 plus 33 is 30. And then I divide by 5, and so x is 6. And then I can substitute and put into one of the original equations. 6 minus y is equal to negative 1. If I subtract 6 from both sides, I get negative y is equal to negative 7, and so y is positive 7. So my solution is 6, positive 7. So the good thing about elimination is that you can make any equation and manipulate it so that you can get rid of one of the variables, okay? So in this next equation, what I look for, I always look for a positive and negative sign variable. So if you'll notice the y, I have a positive y, and then I have a negative 3y. Now, my brain tends to always go to multiplication, but some students recognize that they could make this a little bit easier by dividing this bottom equation by 3. And so then I get 2x minus y is equal to negative 5. And then I have 4x plus y is equal to negative 13. So that's one way you can do it. Now I can see that my y's are going to cancel. So I am going to draw my line. 4x plus 2x makes 6x. This eliminates. Negative 13 and negative 5 make negative 18. And then I divide by 6, and so x is negative 3. Okay, and then I'm going to substitute. Doesn't matter where I substitute. I can substitute in the top equation, the bottom equation. I tend to like to keep positive numbers, so I'm going to take 4 times x plus y is equal to negative 13. And so that says negative 12 plus y is equal to negative 13, and so y is negative 1. Now, I'm going to show you an alternative way. Let's say if I didn't divide, but I did recognize that I could multiply this equation by 3. Okay, what I tend to do is I like to multiply it out and write that equation underneath. And then I tend to box the two equations that I'm going to add up. And so 6x and 12x makes 18x. The y's still cancel. And then I've got negative 15 and negative 39, and that's going to be negative 54. And then when I divide by 18, I'm still going to get x is negative 3. So you can do that problem, you know, either way, whatever is easiest, and then you're still going to substitute the x in, and you're still going to get the negative y. So your solution is going to be negative 3 and negative 1, okay? Now, you can't divide out by every one of those, so then you have to look and say, okay, again, my mind goes to multiplication. So if I look at the variable that has a coefficient of 1, and I see that underneath of it, it has a 5x. So in order to make that 1x cancel out with the 5x, I need to make it a negative 5. So I'm going to multiply everything by negative 5. So that gives me negative 5x minus 20y is equal to negative 70. And then again, I like to box up the two equations that I'm going to add. And so the x's cancel. 3y minus 20y makes negative 17y. And 2 minus 70 makes negative 68. And so then I'm going to divide by negative 17. And so y comes out to be positive 4. And then I'm just going to substitute it into one of the original equations. So I'm going to take x plus 4 times 4 is equal to 14. So x plus 16 is equal to 14. So x is negative 2. So my solution is negative 2, positive 4. Now this one is twofold because it's got decimals. So a lot of times, you know, students they'll see that they can divide and get, you know, the bottom equation. They can divide by 2 and get the same answer. Or you can look at the top equation, and if I multiply by 2, I'm going to get something to cancel. So that's what I like to do. I tend to like to multiply rather than divide. I don't know why, but just kind of goes with my brain a little bit better. So 2 times negative 1.5 is negative 3x. 2 times positive 0.3 is positive 0.6y. And 2 times negative 7.2 is negative 14.4. And then I box up my two equations. And then what happens is, notice this, the x's cancel, the y's cancel, and so to make sure I know I have 0 on the left-hand side of the equation, I want to write that. And 12.4 minus 14.4 is going to be -2. And there is never a time where 0 is going to equal -2. So this is kind of a note when both variables cancel, you are either going to have no solution or infinite solution, okay? And because this right here is an untrue statement, then this problem has no solution, okay? So that's the thing to look out for, is when variables cancel completely out, you know that you've got something that's going to be a little bit tricky, okay? So in this one, again, I noticed some of my students in the class noticed that you could simplify by dividing everything in this bottom equation by a -2. And so that's going to give you -2x minus y is equal to -6. And then on the top equation, you have +2x, positive y, and +6. And when you add these two equations together, the x's cancel, the y's cancel, and so that gives you 0 on the left, and 6 minus 6 is also 0. And so that is an equal statement. So we have infinite solution. You would get the same thing if you decided not to divide. So I tend to do this. So if I didn't divide, I would have multiplied this top equation by -2. And so I would have gotten -4x minus 2y is equal to -12. And then I would have boxed these up together, and then I would have gotten the same thing. So, whoops, don't move my box. Sorry. So I would have gotten the same thing where these canceled and I got 0 is equal to 0, which is infinite solution, okay? Now the next example, because we are using system of equations, we're going to do this using system of equations. And so there are different ways to do this, but you're given 2 points. Here's your first point. Here's your second point. And so what I do right here is I label this as your first x and your first y. And then I label this as your second x and your second y. And so equation 1 is going to be, take your y, which is 1, take your x times your m plus your b. So again, I've got an equation, I've got 2 unknowns. My unknowns are m and b. Then you're going to write your second equation. Actually, I'm going to write equation, this is equation 1. And then equation 2 is going to be your y, which is -4, your x, which is 8, times m plus b. So to make this easy to use by elimination, I am always going to take that top equation and multiply it by -1 so that I can get my b's to cancel. So now I'm going to have -1 is equal to -1m minus b, and then I'm going to add these two equations up. And so -1 and -4 make -5. 8 minus 1 makes 7m, and the b's cancel. And then I divide by 7. And so m, which is my slope, is -5/7. Now they want the equation, they want the final answer to be in this format. Y equals blank x plus blank, which is b. Okay, so right now we've already figured out that the slope is -5/7. Okay, and so what we're going to do is we're going to go back and substitute into one of the original equations. So 1 is equal to 1 times -5/7 plus b. I'm going to add 5/7 to both sides. But remember, I can't add 1 to 5/7, so I have to change that to 7/7. And 7/7 plus 5/7 makes 12/7, and that's B. And so then I would put 12/7 here. So this right here is the answer that they're looking for, okay? So they want the equation in slope-intercept form. Now, I know there are other ways to do this, but because we are in system of equations, this is how I want you to approach this problem, okay? All right, so let's try another one. So here we've got equation 1. Here's my x1, y1. So we get y is 5 equals 3 times m plus b. Equation 2, here's my x2 and my y2. So y is 2 equals negative 6m plus b. I'm always going to multiply that top equation by negative 1. So now I have negative 5 is equal to negative 3m minus b. Box these two equations up. And then cancel out the b's. 2 minus 5 is negative 3. Negative 6m and negative 3m makes negative 9m. Divide by negative 9. And so your slope is 1/3. Then I'm going to replace that into the top equation. So 5 is equal to 3 times 1/3 plus b. That makes 1. And so b is equal to 4. So your equation, remember they're looking for an equation, y equals 1/3 x plus 4, okay? All right, now these next problems, you want to make sure that you notice how the equation is. And now this one, I'm gonna leave this off. I do not want you to do this one by the method of addition because I think this one is set up ideally to do substitution, okay? And really, so what you should know about these is that you should know which equation is the better one to use or which method is the better one to use. And so in this case, anytime I see x, I am going to replace it with y. And so now I get 63 plus 75, I get 138y is equal to 276. And then when I divide by 138, I get y is 2 hours, which is the same time that they are traveling. So they're both leaving Chicago. One's going this way and one's going this way. And of course, one bus is driving a little bit faster than the other, or truck. One truck is traveling a little faster than the other, but their total distance, they're going to be 276 miles apart, and they're going to be driving for the same amount of time. And so that's why the x is equal to y, okay? So this one, I would probably simplify these. And so I think I'm going to divide that first equation by 0.4. Whoops. So I'm going to get x plus y is equal to 9. And then just to get my opposite variable, I'm going to divide everything by negative 0.8, okay? So if I divide, so this one I'm going to say divide by 0.4, and this one I'm going to divide by negative 0.8. And so that's going to give me negative x minus y is equal to negative 6.5. And so when I add these two equations up, the x's cancel, the y's cancel, which gives me 0. And then I've got 9 minus 6.5, which is a 2.5. and that is not true, so no solution. Okay? All right, let's see. Got a few more here. Okay. So this one I'm going to simplify by dividing everything by 8. So I get x plus y is equal to negative 3. This one, I think I'm going to divide everything by a negative 2. So I get negative 2x minus y is equal to positive 12. And then I'm going to add these two up. So x minus 2x is negative x. That cancels. 12 minus 3 is 9. Divide by negative 1. And so x is negative 9. And then you could plug it back in. I'd probably use this one. So negative 9 plus what is equal to negative 3. So y is equal to positive 6. So negative 9, positive 6. Now, on this next equation, it's not in the correct format, so I want to get my x's and y's. You know, you could do one of two ways. If you had the option to do this one, I would probably choose to do substitution. So I would do this by dividing everything by 5 so that I get this. Okay, 5y divided by 5 is y. 10x divided by 5 is 2x. Negative 30 divided by 5, which is not negative 15, sorry. Negative 30 divided by 5 is negative 6, okay? All right, and then I would substitute it in here. So negative 4x plus 2 times 2x minus 6 is equal to negative 8. So I get negative 4x plus 4x minus 12 is equal to negative 8. These cancel, and now I get negative 12 equals negative 8, which again is not true, okay? And then last but not least, let's divide, or let's just multiply. Let's go ahead and multiply this by a negative 1. And so that makes positive 4x minus 2y is equal to positive 12. And if I add those two equations up, stretch that out a little bit, I get the x's cancel, the y's cancel, which is 0. 24 and 12 make 36. Not true. No solution. Okay, so just be aware of those. That's going to finish 11.3 on addition method or the substitution or the elimination method.